One of the most frustrating yet exciting things about physics is that things are rarely constant. Depending on your frame of reference, location in the universe, mass, and more, what one experiences is rarely the same for everything and everyone around them. This means that when something, across all planets and solar systems and galaxies, appears to be the same, it's a big deal. And this magical connecting factor? Gravity. Gravity is the one thing that keeps everything in place, staying in orbit and following systems. Without it, planets and other celestial bodies couldn't be compacted into objects as they are today, and they'd be nothing more than particles of matter floating around in space. Without gravity, we couldn't survive. Yet before we get into the universal properties of gravity, we must discuss its history. We recognize Newton for being the first to create the laws of gravitation, but he wasn't the first to speculate. Aristotle thought objects could be moved by natural or violent motion, and it was only natural for planets to orbit. However, Aristotle, being a good philosopher yet a mediocre physicist, also thought an object needed a force against it to stay in motion. Galileo disproved this through a series of experiments. An object in motion does not need a force to stay in motion so long as there's not a net force against it. Sound familiar? Yet this poses a new problem. To accelerate, objects need a force against them. And since acceleration is a change in speed and direction, and planets don't orbit in a straight line, they orbit in an ellipse, they're accelerating. So what is this force against them? Kepler assumed it was something like magnetism, and even Hooke suggested gravity before Newton, yet with far less accuracy and detail. Newton was the first to completely understand that an apple falling from the tree in his backyard was the same thing as the moon orbiting the Earth. It's gravity. From this, derived from his second law, force equals mass times acceleration, he derived his law of universal gravitation, where the force of gravity equals the gravitational constant times the mass of both objects divided by the distance of their separation squared. This means that the force of gravity is directly proportional to the masses and inversely proportional to the square of their separation. The cool thing about this, though, is this happens everywhere. We pull on those around us, our eyes pull on each other, we're even pulling on the moon right now. Everything in the universe, no matter how small, has a universal force on everything else. And us being humans are too tiny to make a significant difference in anything. Yet it's still comforting to know that in a universe where so much is unknown, we know one thing connects us for sure. Gravity is everywhere and holds us, as well as everything else in the universe, together.